Hello, everyone. It's a great honor for me to be here today speaking for CyberCrimeCon 2021 and welcome you all to my talk. Before we start, I would like to take a chance to introduce about myself and my company. I am currently a security researcher at VNPT Cyber Immunity in Vietnam. I am doing security now for 3 years, and mainly I focus in web applications and Java and .NET platform. And I have found many bugs in Oracle products. Most of it are server-side and have high impact. About VNPT Cyber Immunity, we are one of the leading security company based in Vietnam. We are providing 4 services, which are managed security, security assessment, security training, and security consulting, and 2 solutions of DNS protection and smart IR. That's all about me and my company. Now let's take a look at the agenda. First, I will start with some basic Java serializations, how serialization and deserialization working. After that, I will talk about what could go wrong when deserialization in Java that led to vulnerability. And finally, we're gonna end this section with vulnerability detections and mitigations. Let's get started with the first sections, Java serializations. Understand this concept will help you knowing the root of the vulnerability. Here I have a model describing the serialization and deserialization process. So basically, when you want to convert an object into a byte stream and save it to a format such as files, database, as well as transmit it over the network, we use a serialization process. And vice versa, we use deserialization process to convert the above data back to object formats. In Java, the class needs to implement the serializable interface to be serialized. Classes that do not implement the serializable interface are not compatible with the process. And the writeObject method is responsible for writing objects to the stream. The readObject is corresponding methods used when restoring the values written by the writeObject method. Another way to make a class serializable in Java is to implement the externalizable interface. This interface implements the serializable interface, but moves the responsibility of serializing and deserializing to the class. Here is an example for the upper process. I will serialize a variable named time, and both of them are string. As you can see, the string class implements the serialized interface, so it satisfies the condition as mentioned above. After that, I use the writeObject method to save the values of the 2 variables to the file demo.ser. The content of the files consists of the byte stream. Let's take a closer look at the structure. I used a serialized dumper tool for parsing and got the following result. These 0xACED represent the stream magic, and the 0x0005 represent the stream versions. A quick note here is on serialized data starts with these bytes. Next, the byte 0x74 represents the serialized data type, and after that is the length and the value of the data. Then, if you want to get back the state of 2 variables, you can use the readObject method and get the same results as the original. So what is Java serialized data used for in real life? I will list out 5 functions as communications, persistence, synchronizations, cachings, and finally is deep copy. Communications allows services and applications to communicate with each other by sending data that can be processed. Persistent In Java, serialization allows preservation of objects and their states by serializing the object. Synchronization allows serialization to work across different Java virtual machines. And caching serialized allows an application to temporarily store frequently accessed data. And finally, deep copy. Deep copy is the ability to copy an object along with our object reference within that object. So what could go wrong here? What can be happen in the deserialization process that lead to vulnerability? We will go on with section 2 to clarify this. The core problem causing this vulnerability is that we do not check the input serialized data, and an attacker might be able to insert a malicious object into the data stream. But to exploit the deserialization process lead to vulnerability, applications need to meet two criteria. First, the target needs to have an entry point that allows us to send our own serialized object to the target for deserialization. And second, the vulnerable class must be present on the class path of the application for us to create a GADGET chain. I will talk about the two conditions in more detail in the following parts. Next, we will get to know what is magic methods and what is a GADGET chain. Magic methods, also known as the source, are methods that are run automatically during the deserialization process and can be mentioned as read object, read results, validate object, or finalize. The magic method is used to run code during deserialization. So after that, we can see that how we can use this magic method to the exploit process. So what is a GADGET chain? A GADGET chain is a compile of a GADGET, and a deserialization GADGET is a class residing within the application code or library. It must be reachable by the Java class loader. The class can be used to facilitate an attack. I have some example here. I serialize the GADGET class and assign the comment variable of this class with the CALC command. Then when the deserialize process takes place, the read object method will be automatically called, at which point my command will be run. Here, the GADGET class can be thought of a GADGET, and a GADGET chain is a combination of exploit class and GADGET class. Next, we will analyze a case study, CVE 2021-2302, Java Deserialization RCE on Oracle Business Intelligence, discovered by myself. This vulnerability exists in the product's Oracle platform Security for Java, which is a framework that can be used in Oracle's as well as third-party environments, including Oracle Business Intelligence, which is exploited via the T3 protocol. The T3 protocol endpoints filed by Folklore Security in 2015. We see the magic by ACED0005 appear in the stream. This means that this protocol performs serialized data transmissions. On the left is the Python script that Folklore created for the exploit. First, the script establishes a TCP connection to the target, and next send a message to tell the target that we want to talk using the T3 protocol and wait for the response. The last part is custom serialized data part. There are many Java deserialization vulnerabilities on the platform that have been filed since 2015 until now. Because Oracle decided to fix the vulnerability using blacklist of GADGET chains, we can bypass this mitigation by finding a new one, and this is how my CVE is found. Let's get into the vulnerability detail. First, I want to mention the sink where the RCE trigger is located at the methods where getResult principle in class unresolved principle. The brief operation flow of this method can say as follows. In line 58, the code lost a class whose name is a string taken from a method this.principal entry .get class name, and after that continue looking in the class loaded above for a constructor that takes a string argument, and finally created a new instance of that class and passed the argument value from method this.principal entry .get name. So to take advantage of the above lower code leading to RCE, we need to meet two conditions. We need to have control over the variable principal entry, from which we can get control the return value of method this.principal entry .get class name, and find a class that has a constructor that takes only one argument, which is a string, and the code in that constructor is vulnerable. In this case, the variable principal entry is declared with the private keyword, so we can completely control the value of this variable when writing the payload using Java reflection. And the condition one is met. A quick note here is in Java, if a variable is declared with the static or transient keyword, it usually cannot be controlled. Go on with condition number 2. I found a shiftable class named self-session. As you can see, the constructor of this class takes a string argument name init, then passes into the exit method. The exit method will execute a val impression, which can be used to lead to RCEs. So that we have the condition number 2 is met, and continue to find the entry point. As you know that the source, we can easily find a magic method with object in the class but attribute value exception. This method will be automatically run during deserialization and call to class unresolved principle. And let's put it all together. We get the full GADGET chain like this. Each piece of code calls each other from entry point to where the code can take advantage. And finally, our final task is to write a payload. Here I'm using the Java reflection to control variable value and generate a custom serialized data. Running this payload will pop the calculator off on the target screen. This means that we can able to RCE successfully. And I have a video here to describe this process. To wrap up the session, I will show you a few ways to detect and prevent vulnerability. If you want to know whether a product has this vulnerability, you should check some of the following things. The first thing is obviously that Java serialization object stream always start with magic by 0xAC 0xED in hex and R0ASPX in base 64 encode. And if the data is transmitted via HTTP protocol, then its header will look like this. Content type, application X Java serialized object. If you see this size, the data is serialized when sent. Then you can use the WSO0 tool to put forth the available payloads. Why SOCIAL is a collection of utility GADGET chains discovered in common Java library. And also, you don't forget to check your third-party libraries. It may have hidden vulnerability that you don't notice. And if you have control over your source code, check the code as follows. This code is doing the deserialized data without any validation. You can also find GADGET chain by yourself. Keep an eye out for the following dangerous methods like invocation handler.invoke and method handler.invoke. Usually there will be a large number of libraries. It means a large GADGET space, and finding GADGET manually will be very time consuming. And I recommend you to use GADGET inspectors. This tool will automatically discovering possible GADGET chains in an application class path. And its help penetration tester can quickly construct an exploit. Moving on with mitigation. The first one is really obviously that do not accept untrusted serialized data. These vulnerabilities are dependent on application allowing untrusted data to be deserialized. This mitigation might require significant re-architecting of software communication protocol. And if your app really needs to accept input from an untrusted source, you will need some method of filtering like whitelisting or firewall blacklisting. A whitelisting accessibility only allows classes that are approved by the developer. And blacklisting uses the same principle as blacklisting for disallowing, and web application firewalls can help mitigate deserialization vulnerability by examining packages before they reach the deserialization endpoint in the application. In the 3 types of filters, I don't recommend using blacklist. It's very easy to bypass. Another option is you can use a security manager. In Java, define a security policy that should be enforced within an application. The security policy is responsible for defining which actions are unsafe or sensitive with the application context. Finally, you can consider using other formats such as JSON or XML, but these formats are generally less prone to vulnerability. However, you should still be careful. Some researchers have found similar vulnerability in the formats. And the conclusion is Java serialization is a great thing, but also can be super dangerous if we do not control serialized objects. 2 things are needed to successfully exploit this vulnerability is you need to have an entry point and a GADGET chains. The concept of the entry point is quite easy to understand. Then the GADGET chain, you can think of it like a Scrabble game. The code will be called to each other like when you concatenating words together. And finally, there are many ways to prevent this vulnerability, but don't use the blacklist. It's really a bad idea. And that is my presentation ends here. If you have any questions, hit me up online. And again, thank you for being here.